Hey everyone, welcome to SingularityComputers Client Build 9. This is going to be a mid-range water-cooled build built into the Bitfenix Prodigy. The color scheme is going to be black and white. I'm going to be doing custom cables. The water cooling loop is going to be high-end, and it's also going to involve some modding. I'm going to be doing some substantial mods to the case and also some minor mods to other components. I'm now going to get started with a brief overview of all of the components. I have here the white version of the Bitfenix Prodigy, but I'm actually going to be using the black version. I have an Intel Core i5-3570K, Gigabyte Z77N Wi-Fi, two Samsung 830 series 256GB SSDs, a 16GB kit of Corsair Vengeance memory, an EVGA GTX 670, and a Silverstone Strider 650W gold. For the water cooling system, I have an EK Supremacy and an EK GTX 670 water block. Both of them are CSQ nickel acetal. I have two Black Ice GTS Gen 2 240mm radiators, a Swiftech MCP35X, and an EK DDC XRes 140 CSQ. I have some Mayhem's Pastel Ice White Coolant Concentrate and an EK CSQ GTX 670 backplate. For the radiator fans, I'm using Noisebocker E-Loop B12-2. Now the rest of the components I haven't yet confirmed if I'm going to be using. I have a temperature gauge, some vandal switches, splitter PCBs, and lighting. I'm also still waiting for some of the components to arrive, so you'll get a look at those later in the build log. So I'm now getting started, and the first thing I'm going to do is strip the case. I'm going to remove everything from the case that I possibly can so that I can start the case mods. I'm going to put links on the screen to my review of the Bitfenix Prodigy because it's going to be easier to understand the modifications that I'm going to do to the case if you're familiar with the case, and also to Client Build 6, which was also into the Bitfenix Prodigy and also involved modding. The second thing I'm going to do is get my cable lengths, and I'm actually going to do this as I'm stripping the case and preparing the case for mods. I like to get my cable lengths as early as possible when I'm doing custom wiring, because custom wiring is a massive time-consuming job. It's not something that you want to do all at once. It's best to spread it out during the build, so that you can do it on and off. So to get your cable lengths, you actually should really have some of the components installed. At the bare minimum, you need to have the motherboard installed and at least one graphics card. Otherwise, you're not going to get accurate cable lengths, and it's extremely important that you do get very accurate cable lengths, because otherwise you could end up having to do your cables again. So all I do, I use a piece of wire, preferably a larger gauge. I'm using 18 gauge because you need to actually sit it into the position that the cables are going to go in. And you need to figure out your exact cable routing when you're getting your cable lengths. And you might be changing the cable routing during your mods, so a lot of that you need to think about. If you're going to be modding and changing cable routing, getting your cable lengths gets a whole lot more complicated, and you might not be able to get all of them to begin with. So I just lay the wire out into position, and then I mark it off with my finger and thumb on either end and measure it. I write down all of the individual cable lengths, and then I come back to those measurements later when I'm making my cables. I've finished getting the cable lengths and stripping the case, and I'm now starting to go through and get measurements for some of the mods that I have in mind for this build. The first thing I want to do is figure out how I'm going to fit two 240mm radiators into the Bitfenix Prodigy, because unfortunately they don't fit by default. I need to have the fans installed on the radiators to get the measurements, so I'm going to take this opportunity to flush the radiators and assemble the fans and radiators. Now, the specifications of the Black Ice GTS Gen 2 radiators, 29.6mm thick, and they have a 30 FPI. People often comment on the very high FPI of these radiators, but what you need to remember is that they have fins that are 25 microns thick, and radiators normally have fins that are 45 microns thick. Because the fins are thinner, it means the gaps between the fins are larger, so you end up with a fin density that allows for good airflow even with lower RPM fans, but a fin count that means massive performance. The specifications of the Noisebocker E-Loop B12-2, 1300 RPM, 51.1 CFM, 1.042mm H2O, and 16.7 decibels. I've flushed the radiators and installed the fans, and I'm now just fitting the radiators into the case to get an idea of how and where they're going to sit and what they're going to look like. Now, you can do all of this by measurements, and sometimes I do that. Sometimes I do some of it by visualization, because this is really all about aesthetics. You know, I can measure the radiators out and fit them anywhere, but the question is, what are they going to look like? Are they going to look cramped? So I like to see some of the components in position instead of just doing it all by measurements and all by visualization. Now, I can't use any of the existing mounting holes, and some of you might be wondering why I don't just use a 240mm radiator on the top panel and a 200mm radiator on the front panel, because a 200mm radiator is going to potentially give you better performance because of the larger surface area. And if you want to go for maximum performance and don't want to do any case mods, that is definitely the configuration I suggest you go for in this case. I'm installing a 240mm radiator on the front panel purely for aesthetics. You'll see why later in the build. Now I'm going to start on the case mods. I've masked up and marked out the cuts. These are probably the only cuts I'm going to be making in this case, besides the side panels, because I'm going to be installing side panel windows. So I'm going to remove most of the front panel and top panel. This masking technique protects the paint. It also gives you a clear and easy surface to mark out onto. The tape I'm using is made by 3M. It seems that everything made by 3M is just incredibly high quality. It's a painter's tape designed for masking up, and the reason I use this particular tape is because it leaves behind no adhesive residue when you remove it. I've finished making the first cuts with a jigsaw. I also use a Dremel for some of this. I would have used a Dremel right through, but I prefer to use a jigsaw wherever I can because you can make cleaner and straighter cuts, and Dremels also go through a lot of blades. So I finished cleaning up the cuts with a file, and I still need to go around the top panel and drill some holes to attach the new top panel. I'm now working on the front panel. I've made the vertical cuts with a jigsaw, but I couldn't make the horizontal cuts with a jigsaw because there's parts of the case that are too close behind the front panel and the jigsaw blade would have hit. I ended up having to do the curves with the Dremel, and you know, it's a lot messier doing curves with a Dremel than with a jigsaw. You can get good curves with a Dremel if you tip it up on an angle and use smaller, worn out blades, but they still are very messy. You just need to make sure you stay within the line, you know, the lines that you've marked, and you can get the rest with a file. I've finished making all of the cuts and cleaning them up. I've drilled holes in the corners of the front panel, and this will be to attach the new front panel. I've also started sanding back the case because I'm actually going to repaint it. After all the changes I make to the case, I don't want to leave any exposed metal. I've actually just finished setting up a new workbench, and this is going to help a lot because my old workbench was terrible. It moved around. It was impossible to clamp to. I've also been collecting a lot of new tools lately. Now, you don't need many tools to mod, and this is something I'm going to show in my upcoming modding guides. I've mentioned I'm going to do these videos. I still plan on doing them. I actually hope to get a gap between client builds coming up where I can catch up on all the videos I've been talking about. But if you do have the tools that you need, you can obviously work a lot quicker if you don't have to do everything by hand. But it gives you a lot more freedom. I find that the only thing restricting me when I come up with a mod, when I come up with a design, is the tools and materials I have access to. I've cut out a piece of 10mm smoked acrylic, and this is going to be for the front panel. I'm just using my new drill press for the first time. I actually used it for the very first time on camera, and this is going to help massively. Now, acrylic is really one of the staple materials when it comes to modding. There's so many different things it can be used for, and if you want a material that is easy to work with and easy to shape, then a thicker acrylic is definitely the way to go. Some of you will have seen what I did in Cytotoxic, the most recent system that I built. I used 10mm acrylic to make reinforcing for the water cooling loops. You can shape it however you want to. And that's what I'm going to be doing to the front panel. I'm going to be hand shaping it. I'm now cutting some holes in the acrylic, and these are going to be for ventilation because I'm actually going to mount one of the 240mm radiators directly to the acrylic. And I'm going to have the noise blocker E-loops visible in the acrylic. I would actually like to have the fan blades completely exposed, but I'll probably end up using mesh in front of them. I'm going to come back to the mods. I'm now going to start assembling some of the components ready to be installed into the build. So first of all, the CPU, motherboard, memory, and CPU water block. Case mods can take a long time, and while you're doing your case mods, there is other things you can do. You can prepare all of the components ready to be installed, install your water blocks, do custom wiring. Usually what I do is case mods in the daytime, and then at night I prepare the components. So that's when I do my custom wiring and all the rest of it, so that when the case mods are finished, you can assemble the build as quickly as possible with nothing to hold you up. So this is the Gigabyte Z77N Wi-Fi, and it's a nice little board. There's a lot of these high-powered mini ITX motherboards now. It's socket 1155, the Z77 chipset. It can take up to 16 gigabytes of DDR3. It has a full-speed x16 PCI Express 3 slot. It has dual BIOS, plenty of connectivity, 4 USB 3, a couple of SATA 3 ports. It even has dual gigabit LAN ports. It's also aggressively priced compared to some of the other options out there, so it's great for a high-powered HTPC build or even a compact gaming build, which is exactly what this is. So here I have the 16 gigabyte kit of Corsair Vengeance DDR3. It runs at 1600 MHz, 99924, 1.5 volts. It's been a while since I've used EK nickel acetyl water blocks. I'm usually using nickel plexi water blocks by request. And the reason I'm using nickel acetyl in this build is to match the color scheme. I actually think that the CSQ design doesn't look so bad on nickel acetyl. It just doesn't seem to be as visible. EK has actually recently released the EK Supremacy Clean, which has no circles, and the Plexi version is perfectly transparent. There's no frosting. It's an amazing looking water block. I'm definitely going to be getting some in coming up. So I've installed the CPU water block and memory, and the motherboard is now ready to be installed into the build. Now moving on to the SSDs and some components that just arrived. So I have here the two Samsung 830 series 256GB SSDs, a Silent Max hard drive silencer, two UN SSD mounts, and a Seagate 4TB hard drive. Now I use Samsung 830 series SSDs a lot in my builds, but I'm using them in this build in particular because of their aesthetics. They have a brushed black aluminium finish, and this is a finish that I'm going to have a lot around the build. It also matches up perfectly with the brushed black aluminium finish on the hard drive silencer, which worked out well. They're a great looking SSD, and they're actually going to be visible from the outside of the build as part of the mods. I often mention UN mounts. They're one of the components that nobody really thinks about because they're always behind the scenes. I find them useful for just about anything. I often mod them and use them for things they're not meant to be used for, and I've used one in just about every single system I've ever built. They're extremely high quality, they have great aesthetics. UN makes two different types of SSD mount, and between the two you can mount an SSD anywhere inside of a case. There's not many situations where I find a hard drive silencer to be useful. It's been a long time since I've used one. Usually you don't need to provide any extra cooling to a hard drive or silence them. Usually I use hard drives that are quiet enough. Most of them fit directly into 5.25 inch bays, so they're great if you're modding and you've removed all of your 3.5 inch bays. In this case I've removed all of the bays, and they're also great for that because they massively improve the aesthetics of a 3.5 inch drive and allow you to mount a 3.5 inch drive anywhere in a build. And the aesthetics of this hard drive silencer are just awesome. It's all black brushed aluminium, and the fins look great. It's actually going to be a feature in this build. It's going to be highly visible. The installation was very quick and easy. I had to install some thermal interface material and foam around the hard drive, and it has rubber mounts to mount it into a 5.25 inch bay. The wire coming out of the side is actually to earth it. You can see it's easy access. It doesn't increase the size of the hard drive too much, and it provides massive cooling, claims to provide up to an 80% noise reduction, and it's also lightweight. Now moving on to the pump and reservoir, I have here the Swiftech MCP35X and the EK DDC XRES 140 CSQ. The MCP35X is a powerful little pump. The specifications are 4.4 meters of head, 17.5 liters per minute, and 22 psi. It's a PWM pump, so you can connect it up to your motherboard and run some fan profiles to control the RPM of the pump. In most loops it's not necessary to do this, because even at full RPM this pump is incredibly silent. But in smaller loops, such as this one, I found it can be a little bit loud at full RPM, and it's certainly not necessary to have it running at full RPM, so I usually set up a fan profile and make sure it spins down as much as possible most of the time. I think the minimum RPM is 1300. Now, I've used the older version of the EK DDC XRES 140 in a lot of builds, and it's an excellent component. With the CSQ version, EK has made some big improvements to aesthetics. The DDC XRES is a pump top for DDC pumps with an integrated reservoir, so it has a thread in the top of the pump top, and you can actually install a number of different sized reservoir tubes available from EK. This is obviously the default reservoir tube. There's also a D5 version of this component. Now, there's a number of different benefits that come with this component. First of all, there's performance gains. This pump top potentially gives higher performance than stock DDC pump tops. Also, because you're integrating the pump and reservoir, there's no fittings in between, you're going to get performance gains out of that. Integrating two components gives far better aesthetics. It's cleaner, it also takes up less space. This also gives you more inlet and outlet options. There's two inlets and a single outlet, but if you could get a multiple opening top for the reservoir, it's going to give you even more options. So you can see the quality of the construction. The reservoir tube is incredibly thick. The design is excellent. The threads on the reservoir tube are on the outside instead of on the inside where they usually are. I've disassembled the pump, and this is what you need to do to connect the pump to the DDC XRES. Sometimes the pump top will come off on its own, sometimes the base will come off like this. Either way, you're voiding the warranty of the pump anyway. There's a warranty void of remove sticker that needs to be removed. So this is what the inside of the pump looks like. There's an O-ring at the top underneath the pump top, and this is the stock pump top that needs to be removed, and this is going to be replaced by the DDC XRES. It's just 4 bolts to attach it to the DDC XRES. The XRES comes with this piece of foam which is for anti-vortex. It will also act as a filter. Now you can install this, or you can use the acrylic with the EK logo that is installed by default. It also comes with this extension fitting which is for the inlets, which are recessed. I've assembled the pump and res config, and it's an excellent looking config. It's compact. Now, this is actually one of the upgrades that I would recommend before anything else. If you're building an entry-level water cooling system with the bare essentials, an integrated pump and reservoir. It just cleans up a loop so much, having 2 separate components integrated, and also it gives you all of those other benefits that I've mentioned. So the graphics card water block, and backplate. The EVGA GTX 670, I use EVGA graphics cards whenever I can because I find everything about them is excellent. Quality, aesthetics, warranty, they come with great accessories. When it comes to CSQ backplates, I've never been a fan of the CSQ design. I've just said that I don't really mind it. I would much prefer the old design though. I think it suits some components but not others, and backplates is one of those components that I would much prefer the old design on. I was just thinking the last time I used nickel acetal water blocks was on GTX 580s, so it's been a long time. Nickel plexi is certainly a lot more popular. I just wanted to show the EKFC Bridge Single. This is the EKFC link that comes with most EK graphics card water blocks. The EKFC Bridge Single looks fairly similar, but the difference is it mounts on the end of the water block, and it gives an extra inlet and outlet, so 2 inlets and outlets. And it actually gives the same options that the old EK graphics card water block design had. So an inlet and outlet on the top and bottom of the graphics card water block. The EKFC link, on the other hand, only gives a single inlet and outlet facing out of the side of the water block. In most builds, you'll need to run your tubing routing across the graphics card, so with the EKFC link, you end up needing to use 90-degree fittings. So for most builds, the EKFC Bridge Single is the way to go when using a single graphics card. With multiple graphics cards, it's all different again. So this is a nice looking compact configuration with the nickel acetyl water block and the CSQ backplate. They match up nicely. So finally, the power supply, the Silverstone 650 watt gold. In the Bitfenix Prodigy, you're fairly restricted as to what power supply you can use because of the length. Now, you can easily just mod the case, but that wasn't really an option in this build because of the other mods that I'm doing. The basic specifications of this power supply: 54 amps and 648 watts on the single 12 volt rail. So as I've mentioned, I'm sleeving everything in NDPC black and white and customizing the lengths of all of the wiring. I'd like to show some of the process of customizing the lengths of the wiring because it's really something that should be done in every build, mainly small builds like this where you don't have any room to tuck away excess wiring. I also still plan on doing wiring guides coming up. That sums up this video. Thanks for watching. Please subscribe, like and favorite if you want to see more.